All right, so for the next one, we'll do some more examples of permutations. Some more easy stuff. What we're doing is we're finding out how many objects we have and what's the rate we're going to select them with. All right, so if we come over here, we'll be taking a look at the first question, which says, find the number of, Jim has 6 books. So right away for both these problems, n is going to be equal to 6. It says, find the number of orders in which 6 books can be arranged on the shelf. So if I'm taking 6 books and I'm putting them 6 in line, this is just going to be 6 permutation 6. We'll find out what the number is there. On the next one, if the shelf has room for only 3 of the books, find the number of ways 3 of the 6 books can be arranged. So n is still going to be 6. This time the rate is going to be 3 at a time. So we put Treasure Island, Lord of the Rings, and Harry Potter in order, but we can flip those, or we can add a new book like The Hunger Games, and we can add those books in, but we're only taking 3 at a time and putting them on a shelf. So this is just going to be 6 permutation 3. I believe the math is just going to be 6 times 5 times 4. So that'd be 20 times 6, which is 120. Let's see if that works out to be that. This would be 6 all the way to 1. But let's just go ahead and do it anyway. We go over to our website for permutations and combinations. We plug it in. We find out that 6 permutation 6 gives us 720. If we were doing a combination, there's only one way you can do that combination. Now, 6 permutation 3 is going to be 120. I did say that. And if we were doing a combination, there would only be 20 ways to combine, because order doesn't matter. If I just have 3 different books on the shelf and order doesn't matter, that would be a combination. But if I'm suggesting that order matters and I'm ranking them, first book I like, second book I like, third book I like, you end up with 120 different outcomes there. All right, so if we move on to the next one, this is just talking about combinations. Again, this is when order does not matter. Okay, so if we move on, we're still doing our number of objects n, how many things we're talking about, and what's the rate we're going to select them with is going to be r. That'll come second. We move on. This says the number, a gourmet pizza restaurant has 9 different things. So right away, n is going to be equal to 9. Find the number of 2-topping pizzas that can be ordered. So this is going to be 9 combination 2. We'll figure out what that math is. Find the number of 5-topping pizzas that can be ordered. We have 9 different toppings, 5 of which can be ordered. And we just go and plug this into the calculator. But this time we want to know when order doesn't matter, what's the answer going to be. And so as we plug that into our website, we find out 9 combination 2 gives us a combination of 20. Oh, I forgot to hit enter on that. All right, let's go back and fix that. Okay, by the power of YouTube, I could go back and fix it. So 9 permutation 2 is going to give us a 72 if we're doing permutations, but we don't want that for this problem. Order doesn't matter. So there are 36 different combinations we can have for that particular problem. If we come down here and find the number of 5-topping pizzas, we already said this was going to be 9 permutation 5, and that gives 9 combination 5. We're not using the permutation here at this point. We're just going to use the combination of 126. All right. Our last one we'll take a look at, Mary wants to join a book club and offers 10 new books each month. And so we'll end up with our number of objects is obviously going to be 10. Mary wants to buy 2 books. Find a different way she can buy pairs of books. So our rate is going to be 2. So 10 combination 2. Order doesn't matter. She just wants to buy 2 books. So it's not a permutation. It's a combination. Mary wants to buy 7 books. Find the number of different sets of 7 books she can buy out of the 10 that she can choose. So we're going to have 10 combination 7, and it doesn't matter. So we go back in, we plug in our 10 combination 2, 10 combination 7. 10 combination 2 is going to give us 45 different combinations. 10 combination 7 is going to give us 120 different combinations. Pretty simple stuff, pretty simple quiz. The questions will be very, very, very similar. And if you have any questions, let me know. In the doobly-doo, doobly, 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 doo.